Hi students, welcome back. Today we are going to look at another interesting problem called the diameter of the binary tree. Let's look at the problem statement first. The problem statement says we are given the root of a binary tree. We have to return the length of the diameter of the tree. So we are given root of a binary tree and we have to return the length of the diameter of the tree. So how is the diameter defined? The diameter of a binary tree is the length of the longest path between any two nodes. So diameter is the length of the longest path between any two nodes in a tree. So this path may or may not pass through the root. So it's not necessary that the longest path passes through the root. So we have to return length of the longest path in the between any two nodes in a tree, even if it doesn't pass through the root. So how is the length defined? Length of a path between two nodes is represented by number of edges between them. So length of the path between two nodes is nothing but number of edges between them. Okay, let's look at the example. So here in this example, we are given a tree with root 1. Okay, and it has two children 2 and 3. 2 has two children 4 and 5. So what are the longest paths here? 4, 2, 1 and 3. And there is another path which is 5, 2, 1 and 4. Both of them has length 3. There are other paths as well. For example, this is also a path, but it has only length 2 and we are looking for the maximum diameter or maximum length of between two nodes, which is why it has to be either 4, 2, 1, 3 or 5, 2, 1, 3. So the answer is 3. Okay. Let's look at another example. So in this example, we are given a binary tree with root 1 and it has only one child 2. So here there is only one path and length is obviously 1. So the answer in this case is 1. So let's look at the solution with another example. So let's say we are given this tree. So can we say that the diameter of the tree is, so diameter of the tree at root 1. So diameter is height of left tree plus height of right tree plus 2. 2 because we have these two edges connecting to the root. So let's see what the diameter would be if we follow this. So height of left tree. Height of left tree here is, height is 0. Okay. So when height of right tree. Height of right tree here is, we have to recursively find. So we go to left, we reach 6. Height here is 0. Height of 4 is 1, which is maximum of this and this. Okay. Height of 3, node 3 is maximum of this or this plus 1. So we have to first find the height of 5. Height of 5 is again 0. Okay. So height of 3 would be 2. So height of, so the diameter of the root would be height of left plus height of right plus 2, which is 0 plus 2 plus 2. So diameter would be 4. 1, 2, 3, 4. Okay. So diameter is 4 and that is the correct answer. So this need not always work out. This worked in this case because the maximum path is passing through the root. But there can be trees where the maximum path need not pass through the root. For example, if you look at this tree, the maximum path is this one. Okay, and it is not passing through the root. If you follow the earlier way, you will not find the maximum path or the correct diameter in this case. So uh, earlier the formula we used earlier was diameter at a node is height of left plus height of right plus 2. Okay, so this may not always be true. So how can we modify this formula? What we can do is, let's call this CD, current diameter. So diameter at a node can be maximum of, okay, left diameter, right diameter, or current diameter. So at this node, if this node is involved, what is the current diameter? What is the diameter of its left child? What is the diameter of its right child? If we find maximum of those three things, we should find the maximum diameter. So let's see how that works out in this case. So let's say, so here again height is 0. So if we go to the right, again we'll go to the leftmost one, which would be height is 0 for this one. Okay, and diameter is also 0. Okay, so to its parent, which is 6, now height becomes 1. Diameter is 1. Diameter is 1 because diameter is nothing but maximum of left diameter, right diameter here is 0, and height of left plus height of right plus 2. So height of left is 0, height of right is minus 1, plus 2, height would become 1. Okay. So for a null node, which is children of this, height is minus 1 and diameter is 0. Height is minus 1 because it doesn't even exist. So we can't define a height, which is why height is minus 1. For a leaf node, height is 0 because it is the lowest node in the tree. So height is 0. Height is nothing but number of edges from the leaf node in a tree. Okay. So here height is 1, diameter is 0. Now again here, this is again a leaf node. So diameter would be 0, height would be 0. So to its parent, diameter of left child is 1, diameter of right child is 0, and current diameter would be 1 plus 0 plus 2, which would be 3. So maximum of 0, 1 and 3, this would be 3. Diameter here would be 3. Okay, and height here would be maximum of left or right, which is 1 plus 1. So height is 2. So for node 4, height is 2, diameter is 3. Okay. Similarly, so left side is done. So to compute the diameter of 3, we have to now go to the right side as well. Right side again, when you go to the leaf node, diameter is 0, height is 0. To its parent, this will be similar to 6. So height would be 1 and diameter will also be 1. For 8, height would be 2 and diameter will also be 2. Okay, diameter is 2 because diameter would be maximum of left child, right child, and height plus 2. Height of left child plus height of right child plus 2. Height of left child is 1, height of left child is minus 1 and plus 2. So height would be 2. Okay. Now similar, this one is a leaf node. So diameter is 0, height is 0. Here for node 5, height would be 3 because maximum of left child height, right child height is 2 plus 1, height is 3. Diameter is maximum of left diameter, right diameter, and height of left plus height of right plus 2. So diameter would be 4. Okay, 1, 2, 3, 4. So for node 3, now we have left diameter, right diameter, left height and right height. So for node 3, what would be the height at this point? First let's calculate the height. Height is maximum of left height, right height plus 1. So maximum of 2 or 3, which would be 3, 3 plus 1, 4. Height is 4. Diameter would be maximum of 3, 4 or 2 plus 3 plus 2. 2 plus 2 is left diameter, left height, 3 is right height, and 2 plus 3, 5 plus 2 plus 2 for these two edges, 7. So 7 is bigger than both 3 and 4. So diameter here would be 7. Okay. Now at this point, left height is 0, right height is 0, left diameter is also 0, right diameter is 7. Okay. Now if you find the current diameter here, that would be left height 0, right height 4 plus 2, which would be 6. Whereas left diameter is 0, right diameter is 7. So the maximum of all the 3 is 7. So the diameter for the root node would still be 7. That is coming from its right child. Okay. So in the earlier case, we would have written, if we didn't do this max of left and right, we would have written just 6 and we will get a wrong answer. So we have to propagate the max value in the subtrees as well. Okay. So now let's look at how we can implement this. So let's write a recursive solution first. Okay. First let's define. So we clearly need height of the binary tree in this case. So let's define the height function first. So node root. So if we are given a node with a tree with root, if root is null, okay, then height is -1. Okay. If there are no nodes, there is no height. If it is not empty, then we calculate the left height. Okay. We calculate the left height by doing root dot left. We calculate the right height by doing root dot right. So we are recursively calling the same method and we return max of left comma right. So either left or right plus 1. Here plus 1 because we are doing the height. It's not the diameter. Okay. So when you do the height, it is just adding that particular edge. When you do the diameter at this node, it is adding this edge plus this edge, which is why it is plus 2. Okay. Don't get confused on that. Now we have the height function. So to find the diameter, we can use this. So again for the diameter, the base case is if root is null, then there is no diameter. Just return 0. Okay. But if the root is not null, what we do? We calculate the left diameter. How do we calculate the left diameter? We will call the same function. Okay. By doing root dot left. We will calculate the right diameter by doing root dot right. And what else do we need? What was the third argument in our function? Left diameter, right diameter and current diameter. So we have to find the current diameter. Current diameter is nothing but height of root dot left plus height of root dot right plus 2. So in case of diameter, we have to do plus 2 because you got the diameter of this, you got the diameter of this. When you are doing a diameter of this, you have to add both these edges, which is why it's plus 2. Now we have all the three things. We have to return max of all these three. Okay. We have to return math.max of current dia and so we are doing math.max only takes 2 values, which is why we are calling it twice. If it takes 3 values, we could have just called it once. Okay. So what we are doing is we are getting the max of left dia, right dia and again doing a max with current diameter. Okay. That basically gives max of these 3 values. Okay, so let's run this and see. So here if you see, we are doing a recursive call to find the diameter of the binary tree, and we are also doing a recursive call to find the height of the binary tree. We have defined the recursive function. Now if we have to optimize it, like the dynamic programming problem which we discussed earlier, simple memoization will not work here. That is because though we are calling the similar recursion, the returned data is different in both these cases. So here we are returning height, here we are returning diameter. So we have to look at different way of optimizing this solution. Okay. So at this current point, since we are traversing each node twice, this is a order of n square solution. We have to look at bringing it to order of n, which means we have to cut down one of these methods. Okay. So let's see if we can calculate the diameter while finding the height itself. Can we return both height and diameter and use that somehow? So instead of just returning integer height, let's say we return something called a diameter pair. Okay. So let's define that class first. Okay. So this pair has both, or let's call it dia height itself. Since we wrote height first. Okay. So we have a class called height dia which takes both height and diameter. Let's define a constructor for it. So what we have defined is a new data type which contains both height and diameter, and from the height function, instead of simply returning just the integer height, we will return this new height dia which has both height and diameter. Okay. Now when we are doing this, all our return types will also change accordingly. So the base case now would become, what is the height of a null tree? It is -1. And what is the diameter? 0. So we have to return, in the base case, which is when root is null, we have to return -1 and 0. Okay. Now when you do a height of left tree, you will get height dia, not a simple int. You will get, when you do the right also, you will get a height dia. So now when you do the, this is the current height. So this is the height. So you have to return both height and diameter, which means we have to find the diameter also at this point. So what is the diameter? Again, diameter follows the same function. So diameter is nothing but math.max of, what is that? Current diameter and left diameter, right diameter. So what is current diameter? Current diameter is nothing but height of left tree plus height of right tree plus 2. Correct? So current diameter is left tree height plus right tree height plus 2. We got the height. Okay. That is the current dia. And we need two other things, which is left diameter and right diameter. What is left diameter? Since we are holding left diameter as well here, we need not call that recursive function again. We can just say left dot diameter because we already have that value. What is right diameter? Right dot diameter. Okay. So this will give us the diameter. So here if you see, since it holds both height and diameter, we are calculating both the things in a single recursive call. So we will have both height and diameter in this case. Now, when our in the parent, we need not handle this base case because we have already handled that here. We need not call it recursively. Okay, when you can just calculate the height of the tree and get the height dia here. So height dia, okay, or we can just say return height of root dot diameter. Okay, what we did here is this will give us the new data structure height and diameter. Of that we are just picking the diameter and returning that. So the height function we now modified to return both height and diameter, which is why all those recursive calls which we had earlier in this to recursively call the diameter, all these are gone now. Okay, now we will just call the height which also holds the diameter and we return the diameter portion of it. Okay, so let's run this and see. Okay, no suitable method found. Math, okay, here we have to pass integer. No, left dot height, right dot height. So we have to find the maximum of left height and right height. Left and right are not integers, which is why it was complaining. Now let's submit this and see. So it is accepted. Here if you see, there are no two recursive calls. We are only calling the height function once and we are touching each of this node only once. So the time complexity of this method would be order of n. Okay. Earlier implementation, recursive implementation, time complexity would be order of n square. Whereas the space complexity would be order of n because there will be a recursive stack. Okay. So this is a bit difficult to understand. If you work out this problem like how I shown here with different tree examples, it will help you understand. So I'll highly encourage you to work this out on pen and paper yourself to understand the recursive logic here. So as always, keep practicing and improving your problem solving skills. If you have any questions or queries, do leave a comment. Thank you for watching. Please like, share and subscribe.